Welcome back. So in this video, we are going to look at how to graph the FRED data that we downloaded from the Federal Reserve Economic Data from the Federal Reserve Bank of St. Louis in Google Sheets. So we also have a video showing how to graph it in Excel if you prefer to use Excel. But Google Sheets is just as good for this task, and it's free, so that's always nice. So let's go to Google Sheets. And we'll just open up a blank tab here, and we'll go to File. Let's see. All right, so we have our blank Google Sheet. We're going to go to File, Open, and we're going to upload because we saved it to our computer. We'll choose. All right, so here we have it. It was called Opens Philip Exercise 2. All right, so we've got the data here, right? So we've got a little bit of information from FRED up top, and then we've got descriptions of our data sources. And let me just zoom in a little bit so everybody can see a little bit better. So we've got our unemployment rate, which is our unemployment rate in percent, annual, seasonally adjusted. The seasonal adjustment doesn't matter since it's annual data. Our real gross domestic product, percent change from a year ago, so that's real GDP growth, annual, seasonally adjusted annual rate. And then our inflation rate, consumer price index for all urban consumers, all items in U.S. city average, percent change from a year ago, annual, seasonally adjusted. Okay, so I'm going to I'll keep unrate, that seems pretty clear. I'm going to call this our GDP growth, just to be clear, and we'll call this inflation. Okay, so our first graph that we want to do is real GDP growth on the horizontal axis and the change in the unemployment rate on the vertical axis. That's what Open's law is, right? So the idea is if we're growing faster with real GDP, then the unemployment rate is going to go down. And if we're growing slower or even shrinking during a recession, then the unemployment rate is going to go up. All right, so we need to insert here, and we need to calculate that change in the unemployment rate. Now, often when we think of change in an economic variable, we think about percent change, but the unemployment rate is already in percentage points, and if you do percent change of something that's already in percentage points, then it's very hard to interpret. So we're just going to do a first difference, and that just means we're going to do this year minus last year. Now, for 1948, we don't have last year, so we can't do that. So we're going to lose an observation that happens. So we're just going to put equals in 1949, 1949's unemployment rate minus 1948's unemployment rate. And they're already allowing us to autofill. Yes, suggested autofill. We would like to do that. So just click here, and that's going to do that for all of these variables going down. So let's think about what this means. Well, if this is positive, then the unemployment rate is going up, right? It went in 1949, it went up from 3.8 to 6.1 as we demobilized from World War II. And if it's negative, then that means it has gone down, right? And so you can see we had a number of years of pretty strong growth in the early 50s. Okay. So now we have real GDP growth. That's going to be our horizontal variable axis, our X variable axis, and we have the change in the unemployment rate. That's going to be our Y axis variable or vertical axis. We're just going to highlight these. We'll go all the way down to 2020. We can ignore 2021 since we don't have annual data since it's only March. And we're going to go to Insert and Chart, and it's going to insert a chart. This is not actually the chart that we want, although it's kind of interesting. We need to go up to Chart Type here and choose Scatter Plot. So we go down, here's Scatter, there we go. And let's see. All right, so now we've got our scatter plot, right? And we can this actually, Google Sheets does kind of a better job because it labels the horizontal axis and the vertical axis automatically. Then we can also, now what we want to do is go to series and put in a trend line. Now the trend line is going to be the line that best fits this data. So if we click trend line, that's going to give us the line that best fits the data. And by best fits, what we mean is that it's going to minimize the square of the distance between the actual points and the line. And for the label, we can use the equation and we can show r squared. So let's see what this means. So our equation tells us how, just the slope and intercept of the line, right? So our slope is minus 0.409 and our intercept is 1.32. So this is saying that when real GDP growth is 0, the unemployment rate will go up by 1.32 percentage points. And then for every percentage point of growth we get, the unemployment rate goes down by by 0.4 percentage points. So we can see a couple things here. One is that we need some positive amount of growth, somewhere around 3, we'll calculate that in a minute, in order to keep the unemployment rate constant. So how do we calculate that? Well, we just set y equal to 0 and move our x variable over to the left-hand side and divide everything by that coefficient. So it would be 1.32 divided by 0.409, and we get 3.23. So we need 3.23% growth in real GDP every year in order to keep the unemployment rate constant. And that's because we have population growth, so we have people coming into the labor force, and also because we have productivity growth. So we're learning how to do things better every year, and that means we need fewer workers to produce what we produced last year. Now we also have the r squared here. R squared is a measure that goes from 0 to 1 and is a measure of how well this line fits the data. If it's 0, that says this line doesn't fit the data at all. There's no relationship between these two variables. If it's 1, it says these points are exactly on this line and these are two perfectly related variables. We never get anything close to 1 in economics. For macroeconomics, an r squared of 0.69 is actually really good. So this says this is a pretty tight relationship. It's not a perfect relationship. Nothing in macroeconomics is, but it's a pretty good relationship. That's why we get to call it Okun's Law, right? And so we should definitely change our title here. If I can figure out how to do that, chart title. Maybe I just type over it. No. Well, I'll leave that as an exercise for the student. I don't use Google Sheets very often. But here's our graph. We're pretty happy with our graph now. All right, so let's get rid of that. Let's just move it down. I'm not sure how to move it to its own sheet in Google Sheets. So I'm not too worried about that though. All right. So now we also need to do Phillips curve. And so the Phillips curve, we have a couple variations, right? The original Phillips curve was just the unemployment rate on the horizontal axis and inflation on the vertical axis. That fell apart in the 1970s. And what we found was that what fit the data best was the unemployment rate on the horizontal axis and the change in the inflation rate on the vertical axis. So why don't we just copy this over here. That can be our unemployment rate, and then we'll do the change in inflation the same way we did the change in the unemployment rate. So now this is going to be equals inflation, this 1949 minus this 1948. And yes, we would like to autofill. Thank you very much. And so what does this say? Well, this says if it's negative, the inflation rate has gone down. And if it's positive, the inflation rate has gone up. And so what we expect is that a low unemployment rate would lead to higher inflation, and a high unemployment rate would lead to lower inflation. So we're going to just copy this down, stop at 1920. And then we're going to go to Insert, Chart. And they gave us a column chart for some reason this time. We want to go to Scatter. Okay, good. And it's interesting. They didn't give us titles this time. We want to go then, in order to put the trend line in, we want to go to Series. So just click on the data points. And then we want to go to Add Trend Line. And then we want to go to, say, Use Equation, and then Show R squared. So a few things in this data. First of all, our R squared is 0.08, right? So not very good. There's not a lot of tight relationship in this data for the 70-year period. And so if you do a smaller period, you might find a better relationship there. But we can also see some interesting information, right? So first of all, the vertical intercept, which is 2.15, says if we ever had an unemployment rate of 0, which we never do, we would expect the inflation rate to go up by 2.15 percentage points each year. That's probably not that interesting. What's more interesting is the horizontal intercept, right? And so the horizontal intercept is a measure of the natural rate of unemployment, or the non-accelerating inflation rate of unemployment, NAIRU. And it's the rate of unemployment where we don't expect inflation to change. And so again, we can solve for that by setting the left-hand side equal to 0, right? Because that's what the horizontal intercept is, moving our x variable over and dividing by the coefficient. So we get 2.15 divided by 0.387, and we get 5.56. So this says that we would need that an unemployment rate of 5.56 is on average in this 70-year period associated with no change in the unemployment rate. Actually, of course, what we think is that the natural rate of unemployment was probably higher in the 70s and 80s, maybe around 6%, and is lower these days, right? Because we've had unemployment rates below 4% with very little inflation. So this, I think, goes to show both that the natural rate of unemployment changes over time, but it also, I think, shows that this relationship in the Phillips curve is really not as tight as, say, Okun's law. And so I think that's something to keep in mind too. So, you know, if you are doing this graph, you should make sure to add, you know, titles, a title for the graph and titles for your x-axis and y-axis. I don't know why they didn't label them in this graph, and they did label them in our Okun's law graph. Google Sheets is a little bit of a mystery to me. All right, so that's all for now. Thank you for watching, and I will see you in the next video.